given polynomial, then sketch if you need to, compute the location of the y-intercept as a check. All right, so there's two transformations here. The first one is the +5. That is left 5 units.
Mhm.
And it's always opposite what you think when it's inside the function. The negative is a reflection over the x-axis. What is the parent function? I guess we should start with that. The parent function here is x cubed. And how accurate do you think the graphs need to be? Because I can do them in Desmos real quick and snip them in, or I can freehand them. What do you think would be best?
Let me go on the assignment and see if it says to use Desmos. We can just freehand it.
Okay. So the sketch of the parent function is something like this, where it snakes through the origin, and then you're going left 5. So that's kind of arbitrary, but then it flips. So it looks something like that. Is the transformed one.
Got it.
All right, number 4 is the next one I see. And let's see what that is. This one's got more going on here. All right, so there are 1, 2, 3 transformations. The first one is the -3. That's 3 right. The 2/3 out in front, that's a vertical, and it's a compression because the number is less than 1, because this is a, and a is less than 1. And then the +1 on the outside, that's a vertical shift up 1. So again, like if we can do a rough sketch here, the parent function looks like this. Okay, so it's right, like, because we're not trying to be that, it's right 3 and up 1, and then it's kind of compressed. So it's hard to show the compression, but it's something like that.
Yeah.
Okay, the next one I see is number 18. Number 18 says graph the function of viewing window that shows all of its extrema and x-intercepts. Okay, so I'm definitely gonna use technology for that. Let me snip it in. Okay. All right. We can actually do the limits without graphing it. So if you were to multiply these out, and this is very important, you would be multiplying that term, and that term, and you would get -x cubed or -2x cubed. And so that roughly, normally an x cubed looks like this, but because it's negative, it flips and looks like this. So that gives you the extrema behavior. We're going to throw it in the calculator and get some stuff here, but the extrema you can do without that. And you say things like, as x goes to -infinity, y, or f of x, and that's right here, y goes to +infinity. So that's this direction. That's this first line is over here. As x goes to +infinity, that's over here. Y goes down to -infinity. So you can actually do that without graphing. Of course, we do want a graph. So I'll make the graph here, and then I'll give you the appropriate window also, which will be visible from the graph. All right, and then we just need to get an appropriate window here. All right, here we go. So let me snip this in. Oh, I need to get the endpoints here. Let me do that one more time. Does it say to identify the extrema, or just to like show them, like show a dot?
It just says graph the function that shows all of its extrema and x-intercepts. So we don't need to Just need to see it.
Yeah, so you need to see it here, and it was asking for like your window. So it's, you know, from -5 to 6 and -12 to 15, something like that. I'll give you the window. We'll put that 15 here. -12 down there. Well, actually probably -15, something like that. And it's got the same shape as over your top right, so that it's consistent with that there. All right, number 20. So this analysis that I did in the top right, it comes from what's called this term right here, the power term or the leading term. Like all this other stuff is irrelevant. So you just have to figure out like what the highest degree term is, and like what does an x cubed look like? And you already know it does something like this, and that tells you the end behavior. As x goes to -infinity, as you go this way now, y or f of x goes to -infinity, goes down. As x goes to +infinity, f of x goes to +infinity. Then we can graph it and get a window for that. The reason they're probably having you graph is they're trying to show you that like a standard window doesn't give you all the behavior of it.
Yeah.
And you have to make it like either wider or narrower. And like as a student, you might not be used to that. So they're trying to show you, like, hey, you know, this is possible here, -80. Okay. So I got a decent window here to show you what this is. It's much easier to do with technology. Snip this in. So you can see here, you know, x goes from like -10 to 10, y goes -100 to like around 150. And that gives you a decent window to see everything in.
Got it.
22. Okay, so 22. So let's look at 22 here. If you sorry about this in the bottom. If you were to like expand this thing on the right, like this thing would have an x cubed in it, and then there'd be a 2x over here, and they would eventually multiply to give you 2x to the 4th plus a lot of other stuff.
Yeah.
But this is your power term. That's your leading term. That's the one you care about. So what you have to know is like, well, what does an x to the 4th look like? So graphically, an x to the 4th, it might have lots of stuff in between, but it starts high and it ends high because it's positive. So you should have done some sort of analysis in class, like if it's, or maybe your instructor will summarize that for you tomorrow, but if it's an even and positive, it has this shape right here. And that's how you figure out, okay, well, as x goes to -infinity over here, f of x goes to infinity, positive infinity goes up. As x goes to +infinity, so as we go right here, somewhere to the right, f of x also goes to +infinity.
Yeah.
And you can do that before you do any graphing. The graphing will basically just confirm what we just said. So let me do the same thing though. Let me get it into a window where we can see what's going on here. And you'll see we actually had a decent window from before to see all this. Yeah, so let me make it just a tiny bit smaller. You can see here from -4 to 8, and then -100 to, really you could stop anywhere. You can go up to 100 maybe, and that gives you all the behavior that you need. 26. Oh, so 26 is the exact same thing that we were doing using kind of limits and stuff like that. So it's the same thing I was doing up here on the top right.
Mhm.
And it's like now do it without graphing. So this will go
Yeah.
pretty quickly. I will remind you, actually, let me put this down here. There's 4 graphs you need to know. Maybe you already know them. But if it's an odd, and A is positive, it looks like this.
Mhm.
And if it's odd and A is negative, it looks like this. And then there's 2 more you need to know. So the other ones are if it's even and A, which is the leading term, is positive, it starts high and ends high. If it's even and A is I'm sorry, A is negative, then it starts low and ends low. And that's all you need to know to be able to do these. And this gives you all the behavior. So now this one here is odd and A is negative. So
Yeah.
it's going to be the graph that looks like this. So that's this one over here, top
Mhm.
right. So that then you know, okay, well, as X goes to negative infinity, f of X goes to, and that's over here, positive infinity. As X goes to positive infinity, f of X goes to negative infinity. That's this one here. So you have to be, that has to be very clear to you, however that can be made clear.
Yeah, I got it.
All right. Now 28 is kind of your test question because they've not written it in descending order.
Oh, yeah. Okay.
And so it's easy to like just look at that first one. But the first one isn't that. And the sign always goes with it. So it's this one right here.
Mhm.
So this one is even and A is less than 1, or I'm sorry, it's negative, not, I'm sorry, I put less than 1. These are all zeros up here. Positive, 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 or positive meaning greater than 0, less than 0 means negative,
Yeah.
negative, so on. Sorry for messing that up. So down here, you can say, okay, well, it's even, so it either starts high, ends high, starts low, ends low. Because it's negative, it starts low and ends low. So the limit as, not limit, you can do limiting, but it's not necessary here. You can just say it this way because you're not a calculus student yet. As X goes to negative infinity, that's this direction, f of X goes to negative infinity as well.
Mhm.
As X goes to positive infinity, so that's this one over here, f of X goes to negative infinity. And again, we don't really care what's happening in between because we know it eventually goes these directions.
Yeah.
All right, 44.
Mhm.
44. Graph the function of u into this shows all of its X-intercepts approximate all of its zeros. Okay. 44 is a graphing one. So let me snip that in. And I'm going to go to Desmos and just get a window for this. And then I'll also capture the intercepts so you can see those as well.
Okay.
Interestingly, so this one, minus x cubed plus 3x squared plus 7x minus 2, it actually, it doesn't, I guess the thing here is it doesn't have to have it doesn't have to have 3 intercepts, X-intercepts, because some of them are real, some are not.
Yeah.
And this is one of those cases where there's only one real intercept.
Okay.
Yeah, so like I can zoom out, zoom in. You would see like it never comes back. Doesn't like come back down or go back up. This is it. So I think you have to record that point for
Okay.
And so if you need the window, it's that for that, or more. Okay, next, 40, 50,
Yeah.
50. Find the zeros algebraically or graphically. Okay, I really like 50 because we can just graph it. Find them, I think. Doing them algebraically is tough. You would have to use the, you would have to make guesses based on the factors of 110. And that's pretty slow. Hopefully this works. Let's graph them here. Y equals x cubed plus 2x squared minus 109x minus 110. Yes, they're actually all nice.
Okay.
Let me get a window here. Negative 100, 200, ooh, wow, 500. Okay, all right, so let's get them in this snip so you can see it. All right, so here they come. They are shown here. You can see you have to get a pretty tall window to get them, but there are three: negative 11, negative 1, and 10. If you had to do it algebraically, you would use synthetic division to confirm that they actually worked. All right, 58 is a calculator problem. So I'll pull up a calculator. We can do that. Let me get that up and going. So we're gonna enter this data into lists. Let me get that going. Tools. Okay. If you have your calculator, it would be helpful to work along with me. I'll share that screen now, and then all right, so are you seeing this calculator on my screen?
Yeah.
All right, so you go second list, I believe. Nope, stat, edit. Stat, edit. I'm writing this down so you'll have it later on.
Okay.
Edit. And if you already have stuff in your list, you go up to like L1 and you hit clear, enter, and it'll clear everything out. So we want to put in list 1 the X values. So negative, just reminders down there, -2, enter, 1, enter, 4, enter, 7, enter. Okay, and then for list 2, it's 2, 5, 9, and 26. Let me know when you're caught up to me here on this.
Yeah, I got it.
Okay, so after I enter the data, I always do like a second quit just to make sure I don't enter something accidentally there. And then I go back to stat, calc. I'm going to write all this down. So you've got stat, calc, cubic regression. So number 5 on yours, you might be able to, why isn't, 5 on yours, you might have to like use the defaults. It's going to like maybe say like, do you mean the independent is L1, the dependent is L2? I'm just going to hit enter. Hopefully it works. It does. Did you get something like this on your screen?
Yeah.
Great. So I'm going to write down it's f of x equals 0.39 x squared plus 0.59 x plus 2.22. You would have to ask your instructor, hey, Mr. Instructor, how many decimal places do I need to, Mr. and Mrs. Instructor, to go to? I'm just guessing that it's that it is that there. Let me look and see if the next question requires the calculator before moving away from it. 50, 63.
I think we need to do it on like Desmos.
Okay, I mean, this can be done in the calculator.
Oh yeah, because it's quadratic regression.
Yeah, this one's got quite a few parts. Just from the sake of time, like we're gonna go all the way to the end of the hour, but would it be okay if we move to the next
Yeah.
assignment since this is odd, and then we can move through this as much as we can.
Okay. Yeah. Sounds good.
We always come back. Okay. So I'm looking at page 205.
Mhm.
Work smart. Okay. Not helpful. Question 2. Okay.
Yes.
All right. Yep. Let me snip that in, and then I'll reshare that screen. All right, share screen. Share. Okay, and just I put in the commands here from what we did. And you might try that on your own if any of it was unclear. So this one, number 2, it says to divide. Okay, so essentially it's like x cubed minus 1 over x plus 1, and you can divide using synthetic or long division. Do you know if your instructor wants you to do synthetic or long division here?
No, I don't know.
I'm going to assume it's long division because it's the first ones, which is the order it generally comes in.
Okay.
And so it's x cubed plus 0x squared plus 0x minus 1. And those are needed when you do long division here. I thought we did this on your review chapter.
Yeah, we've done this before. I just had to
Okay.
go back and do this assignment.
I see. Okay. All right. So we're trying to get rid of x cubed. So we're going to put an x squared there. X squared times x is x cubed. X squared times 1 is x squared. Okay. And then you subtract, change the sign. So you have minus x squared plus 0x. We want to get minus x squared, so put minus x here. Minus x squared minus x, but then you change the sign so they become positive. And you get x minus 1. So you put a 1 here, that gives you x and a 1, and then you negate. So you get negative 2. This is your remainder. This is your quotient up here, and this is your divisor. So it's quotient plus remainder over divisor. It's x squared minus x plus 1 plus negative 2 over x plus 1. This is your summary statement that they're looking for.
Okay.
And then 4, great, we get to do it again. All right, so the thing you're dividing by goes outside the house, and then inside the house is everything else. If it's missing a exponent, you have to include that. This one is not missing any, so you're stopping there. You have you I don't want to say this. You don't have to make any additions here.
Yeah.
So we want to get 4x cubed. So that means we need x squared, but then we need a 2 to get 2 times 2 gets you to 4. Okay, so that's 4x cubed plus 2x squared. Negate. That's often forgotten. So you get minus 10x squared because you're adding now. Maybe you didn't emphasize it in the previous one. So we need to get to negative 10x squared. So that's negative 5x times 2x. 5 times 2 gives you the negative 10. Okay, so now when we multiply and you get negative 10x squared minus 5x, and then you change the sign of both. And then you add, so 7x minus 1. How to get, this one's a little awkward. How do you get to 2x? How do you get to 7x from 2x? It's plus 7 halves.
Oh.
So it can be that. So 7x plus 7 halves. Change the sign. So this ends up being minus 9 halves. That's your remainder. So your final answer is, and I usually write it off to the side because of all this, minus 5x plus 7 halves. It's that plus negative 9/2 over 2x plus 1. I wonder if there's another one. 8.
Nope.
Yep. 8 is synthetic division, much faster to do. We get that in there. Yep. Okay, so the number that goes in the box over here is the number that makes this bottom 0. So
Oh, yeah.
x minus 3 equals 0, x equals 3. That's why it's in the box there. And then you put the coefficients. If you're missing one, you have to put a 0 there. We aren't missing any, but that's something to think about. Now, you bring this one down, but in reality, there's really a 0 here and you're adding, but they always say bring it down. And then you multiply 2 times 3. So then when you add vertically here, you get 1. 1 times 3 is 3. Add vertically 10. 10 times 3 is 30. This is really bad. Let me just double check. Minus 5 plus 7 minus, okay. All right, well, that's the way it is. So 27 times 3 is 81, and then 82 here. This is your remainder. This is your quotient over here.
Mhm.
And this is your divisor. That's your divisor. So the 2, it was x to the 4th. Now it's 2x cubed plus 1x squared plus 10x plus 27. So all those coefficients, they're 1 degree less than it is now.
Yeah.
Plus 82 over x minus 3. It's always quotient plus remainder over divisor. And that's what you have here. And that's the summary statement in fraction form.
Mhm.
I guess that's what's meant by that. Okay. 10.
Mhm.
All right, I'd like you to try one, please.
Okay.
So give this a try. And I'm just going to step away for 60 seconds or less. I'll just actually grab some water. I'll be right back.
Okay.
All right, I'm back. I will assist here. So we got 3, 1, -4, 9, -3, 3. Oh, they get big numbers all of a sudden. I'm shocked. I'm truly shocked. And then another one. Assume you're getting these same numbers.
Yeah.
Okay. All right, so 1602 over x plus 5. I guess there's one more here. Okay, 12. Wow, this is
Yeah.
Yeah, it's not great. So -2 over here in the box, and then it's for 8th, 0x to the 7th, 0x to the 6th, 0x to the 5, 0x to the 4, 0x to the 3, 0x to the 2, 0x to the 1, -1. 7, 6, 5, 4, 3, 2, 1. Great. Okay, so bring that down, -2. And maybe this is where your instructor means to be smart. So every time you multiply that number, it comes down here.
Mhm.
So the next number is -8, 16, -32, 64, -128, and then 250. Well, 256 would go there, and then it'd be 255. But the point, I guess the point is that like you know what's eventually going to happen because you're just multiplying by -2 each time.
Yeah.
So this is x to the 7th minus 2x to the 6th, 4x to the 5th minus 8x to the 4th plus 16x cubed minus 32x squared plus 64x minus 128 plus 255 over x plus 2. Doesn't really get any better here for the next ones because it's still synthetic division. We're going on to 14. Yeah, 14. Okay. So it says use the remainder theorem, and basically it's just like do the same thing, do synthetic division again, but this time the number at the end is the output. So k equals 1 goes right here. Okay. And then it's 1x to the 4th, 0x cubed, 0x squared, 0x minus 5. So do you want to give that one a try?
Yeah.
So that's the value they're looking for at the end.
Mhm. Okay. And then 16.
Yeah, so 16 is next and very similar here. So let me get this snipped in. Okay, so we'll put -2 in the box. Cubed, there's no x squared, so that's 0. Minus 3, 4. One of the things that's sometimes forgotten, if there's no constant, you still have to put a constant in there.
Mhm.
So 1, -2, -2, 4, 1, -2, 2. So that's your remainder for that one. That's all it's looking for. It's just looking for that particular number. Now we're up to 20. 20. Okay. The instructions in 20, they say decide whether the first one is a factor of another. So basically they're saying like, does this divide evenly into that? And the
Okay.
way you figure it out is with synthetic division. So if the remainder equals 0, then yes.
Okay.
If remainder does not equal 0, then no. So it's pretty straightforward. It's just it's like another like, hey, do the remainder theorem again. 1 or the polynomial division, synthetic division again. So we need the coefficients -1, -15. Okay. And then, bring the numbers down. So 1 times 3 is 3, -1 plus 3 is 2, 2 times 3 is 6, That's +5. +5 times 3 is 15. And look at there, remainder equals 0. Yes. So the answer is yes for that one.
Okay.
I'm sure you've seen this before. You know, I mean, nothing really new here. It's just maybe clarifying things that from the past. 22. 22 is that exam question because it's missing the x squared term, which means that you have to remember to put it in. So 2 goes in the box over here because x minus 2 equals 0. That's how we got 2. 1x cubed, 0x squared, minus 3x minus 2. So again, you bring that 1 down, multiply. 0 plus 2 is 2. 2 times 2 is 4. -3 plus 4 is 1. 1 times 2 is 2. And look at there, another remainder equals 0. Check. Yes, it is. It is a factor.
Got it.
20. So that was 22. Okay, so that gets us through 2.4. 215. What are the instructions on 215? Which one is the first one? Number 3 on page 215. Write the polynomial in standard form and identify the zeros of the function, the x-intercepts. Okay. Okay, and then we got to do that. And now it says to use Desmos, or is that just 51?
Probably just 51. I think it
Yeah,
depends.
it is. Yeah, 51's it's a regression one again. So
Oh, yeah, okay.
you got the answer in the back
Yeah.
if you need to compare it to. All right, we should be in good shape here. So number 3. Number 3 says, write a polynomial in standard form and identify the zeros of the function and the x-intercepts of its graph. Okay, so the zeros and the x-intercepts. Okay, so the zeros are the easy one. It's whatever you set each of these equal to 0. So it's x minus 1 equals 0 and x minus 1 equals 0, which is the same. And that leads to 1. X equals 1 is a 0. And then x plus 2i equals 0. And then x minus 2i equals 0. So x equals negative 2i and x equals positive 2i. So it's 1, 2i, and negative 2i. Those are your zeros.
Got it.
Your x-intercepts are only the real zeros. So it's just x equals 1. So that's why I have to do the zeros first, because the real ones are the only x-intercepts. Is that okay? Is that clear?
Yeah.
All right. Now write it in standard form. This is the absolute worst. You have to multiply these, and then you have to multiply these, and then combine the answers. So these are some of the longest questions to do. So this x plus 2i, x minus 2i. So when you FOIL, you're going to FOIL this. You get x squared minus 2ix plus 2ix. So notice those are going to cancel. Minus 4i squared. I squared equals -1. So these middle ones cancel. That's difference of squares. And then this is x squared plus 4 for that part. And then we're going to FOIL x minus 1 times x minus 1. Okay, so that gets you x squared minus x plus 1. So that's x squared minus 2x plus 1. And then you have to multiply again here. Okay, so if we're going to keep going, and we got another 10 minutes because of the late start, but like if we don't get through all these, you're going to want to like use Wolfram or whatever math aid you like out there to do this to check your work, but it's
Okay.
essentially just x squared times each of these minus 2x times each of these, 1 times each of these, and you combine like terms. So that's x to the 4th plus 4x squared minus 2x cubed minus 8x plus x squared plus 4. And you just combine like terms. So you got x to the 4th minus 2x cubed plus 5x squared minus 8x plus 4. That's your final answer for that. I hope we don't have too many more of those. 8. Okay, so 8's going the other direction. Ooh. You get a tough one to start out here. All right, so 8 is to write this in standard form. So the way you write this is it's always x minus the 0, x minus the 0, and so on. So it's x minus a minus 4. That's for that first one. Then it's x minus 1 minus I. So notice I'm putting in parentheses because that's the whole, that's the 0. And then it's x minus 1 plus I. Okay, so now we want to do a little bit of simplification here. We want to distribute these negatives, x plus 4, and you distribute both. So it's x minus 1 plus I, x minus 1 minus I. Now you always do the I multiplication first. So we're going to do this one on the right here first, these two. So it's x squared minus x. We're doing x times each of these minus xi. Then it's -1 times each of these. I do this in a waterfall, so I try to like line up the things. So this -1 times x gives the minus x. -1 times -1 is +1. So notice that's different than anything we've seen. -1 times I is plus I. So I'm trying to line up things that are matching. I times x is xi. So see, I line those up. I times -1 is minus I. I times minus I is minus I squared. Now it actually is going to go with this one here, this 1, because I squared equals -1. But you can see though, you get x squared minus 2x, cancel, 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 cancel. This minus I squared becomes +1, so it becomes plus 2. Because this right here becomes, this term becomes +1. So you feel really good about yourself, and then you're like, oh no, I got to do this again. Like I just got through. So you got to do x times each of these. X cubed minus 2x squared plus 2x. And then 4 times x squared is 4x squared. 4 times minus 2x minus 8x. 4 times 2 is +8. And again, you get the terms to line up. Makes it easiest to do. To get the right answer. I know I'm rushing. I hope it's okay. I'm trying to
No, I got it.
do the best with the time. Oh, another one.
Mm.
Do you want me to do 10 or do you want me to move on to something else?
Let's skip it. Let's see what 14 is.
Okay. So 10 is much like that. All right, so 14. So -1 has a multiplicity of 3. And what that means is so the -1 is 0. So it's x minus the 0, right? That much is true. The multiplicity goes right here. So this is a cubed. Okay, so because it has a multiplicity of 3, that's why it's a 3 there. And then 3 is the next 0, so it's x minus 3. And then you put a 1 here because it's got a multiplicity of 1. So do you follow that? Do you follow how like this number goes there, this number goes there, and then the powers go. So it becomes x plus 1 cubed times x minus 3. Do we have to write this out? No, I think this is good.
Okay.
I think you can just write it. And the thing I'm not doing, I should have wrote p of x equals P of X equals all throughout the assignment. That may be, if your instructor's harsh grader, they may be looking for something like that.
Mhm.
All right, 14, 16, 16. We need to do 16 because it's got a little oddity in there.
Okay.
Little wrinkle. All right, so -1 has a multiplicity of 2. So that's x minus -1, and then put a 2 there because of that. So this becomes x plus 1 squared. Okay, that's great. Now these always come in pairs. Okay, so what I mean by that is that if it just gives you one of them, you have to know the other one. This is the conjugate pair. They're both there.
Oh, okay.
Okay, this is not the best example to like start out with, but this, if it was like just negative I, then there would be a positive I and a few other things. So it's x minus -2 minus I, multiplicity of 1. So the 1 goes there. And then it's x minus -2 plus I, multiplicity of 1 right there. Now this one we should multiply out. And to do that, we're going to distribute the negative. So it's x plus 2 plus I, x plus 2 minus I. So we should quickly multiply this out. So x squared plus 2x minus xi. Now I'm doing 2 times each of these, 2x plus 4 minus 2i, and then I times x, xi plus 2i minus I squared. So it becomes x squared plus 4x. This right here becomes +1 plus 5. So this is your final P of X down here.
Got it.
Got it. All right. So let's see what else we got here. 17 through 20. What are the instructions? Oh, match the graph. Okay. And let me grab the functions. All right. Okay, so here is the shortcut here. If it has an even multiplicity, it touches. And so that means it either touches like that or it touches like that.
Oh, yeah.
And if it's odd, it crosses.
Mm-hmm.
So it crosses, and that's either like it goes like that or it goes like that, or it could even like bend, but it definitely goes across here.
Okay.
Okay, so let's look at so at -3 it has a multiplicity of 2. So that means it touches at -3. See how it touches right there at -3?
Which one are we looking at?
17.
Okay. It touches at -3. Yes.
Yeah, do you see that? And then at 2 it has a multiplicity of 3, so it crosses. Do you see how it crosses right here?
Yeah.
So this is 17. Now let's look at 18. At -3, it is a multiplicity of 3. That means it crosses at -3. So see how this one crosses here?
Yeah.
And then at 2, it is a multiplicity of 2, so it touches there at 2.
Uh-huh.
That's why it's 18. So see if you can figure out which one is 19, and then obviously the last one will be, the other one will be 20.
Okay, so the bottom right one is 19 and the top left is 20.
Perfect. Excellent. Okay, I won't be able to get these notes to you for at least an hour. So do you have everything written down that you need for this assignment?
Yep, I'm good.
Okay, thanks so much for scheduling, and sorry for the little bit of delay, and I'll see you next time.
Yeah, no worries. Thanks, Matt. Bye.
Great, welcome. Have a great night. Bye now.